Now let's talk about gamma decay. And what is gamma decay? Uh, we understand that if we have a nucleus in excited state, it emits energy in the form of gamma rays and goes into a state of ground state. So to say what gamma decay is, it is basically a spontaneous process. It's a spontaneous process. Spontaneous process of emission of higher energy photons from a radioactive nucleus. So we have a radioactive nucleus, it emits a high energy particle known as photon. Now, this phenomenon is referred as gamma decay. Now, we can think of a nucleus having discrete energy levels. Discrete energy levels. As we have discrete energy levels in an atom, and the only difference that we can have is in case of atom, the energy level difference will be small and of the order of electron volts. And in case of nuclear energy levels, the spacing between two successive energy levels of a nucleus is of the order of mega electron volts. So assuming nucleus to have energy levels and these energy levels are exactly same as that of the energy levels of the atom as a whole. But the only difference is that we have energy levels in nucleus in mega electron volts. The energy difference is very large, but in case of atoms, the energy difference is very small. Now, when a nucleus is in excited state, energy levels or the state, it spontaneously decays to a lower energy level or a ground state, and a photon, a gamma ray photon, is emitted. So if I have a level, another level, so what we have, this nucleus being in excited state, it comes back to the ground state, and while coming back, it emits a gamma ray photon. Now, this gamma ray photon, we can have the energy of this gamma ray photon as h nu equals E higher energy minus E lower energy. So, so what we have here, EH is the energy corresponding to the higher energy level, and this EL is the energy corresponding to the lower energy level, or I should say, EL refers to the ground state and EH refers to the excited state. Now, what happens? Gamma rays are emitted by daughter nucleus in the excited state. So what does that mean? What am I trying to tell here is when there is a jump to the ground state, there is emission of a gamma ray particle, and where from it comes from the daughter nuclei. So what does it mean? This daughter nucleus is basically a result of this daughter nucleus. This daughter nucleus is basically a result of, alpha decay or beta decay. So first, prior to have gamma decay, there has to have alpha decay or beta decay. So once there is alpha decay, the nucleus may be in excited state, and if the nucleus is in excited state, it will try to come back to its ground state, and we will have the gamma ray photons. That's the case. That's the case here. Now, let us try to illustrate this thing in a very simple fashion so that we get a clear idea. Now, If I take an example of, say, Fe20 and 9, and it happens to be in, it undergoes beta decay. So it goes beta decay, so we have beta negative. And what we have here is we have neon, neon 20 and then 10. And for 20, I should put a star here so that I want to make sure that the neon that we have is in excited form. And then what happens, this neon goes into the ground state, and it emits energy. And the magnitude of that energy is nearly 1.63 mega electron volts. So what we have here is neon 20 and 10. So this is the ground state of neon, and this is the excited state of neon. So with this illustration, we can understand that we have a daughter nuclei, which is in excited state, and it tends to go to the ground state. While going to the ground state, we have gamma ray. We have the gamma ray particles that are emitted by this. There is another example of cobalt. Cobalt being in excited state. No, it's not in excited state. It disintegrates, and it emits. What it does is it emits a beta negative particle, and what we have is nickel from it, and this nickel is in excited state. And then what happens is that it goes to a ground state. It goes to a ground state where it emits an energy of 1.17 mega electron volts, and then it goes to another transition, and finally comes to the ground state of nickel in 60 and 28, and here the energy emitted is 1.33 mega electron volts. Now, this gamma decay, it leads to nuclear de-excitation. You have an excited nucleus, it de-excites. So this process of gamma decay is similar to the emission of radiation when you have a transition of an electron in an atom from higher energy level to the lower energy level. So when an electron jumps from higher energy level to the lower energy level, what it does is it emits energy in the form of photons. And during gamma decay, what happens is basically we have to have the atomic number and mass number of the nucleus remains unchanged. There is no change in the atomic number and mass number of the nucleus when it goes from excited state to the ground state. So with this, I would like to end this video. I hope everybody understands. I might have committed mistakes. I'm sorry for that, and that's it.